Welcome to Lesson 5 NF1. We're going to talk about adding and subtracting with unlike fractions. So after this lesson, you should be able to add and subtract unlike fractions using equivalent fractions. So first and foremost, we need to talk about what are all of these things, these fractions, unlike, like, all that. So first we're going to look at the word and I'm going to give you examples. We're going to kind of talk about what they mean. So a fraction describes a part of something. So a fraction, and it's going to be equal parts. So a fraction is always in the form of A over B. And A, so that top part is your part, and it is over the bottom number, which is your whole. So in this case, a good example would be 3. So I have 3 out of 4 that I need to make a whole. The numerator is your number that is on top. Right? It tells you how many you have or that are extra, and if you're talking about mixed numbers. So have or extra. It's also the number that's going to get divided when you're converting. It is the dividend. Makes sense then that the denominator is going to be your bottom number. And this one tells you how many you need for a whole group. And it's the divisor, it will do the dividing. Like fractions, so think of like as in terms of they're alike. Like fractions are fractions that have the same denominator. So a like fraction to 3/4 would be 1/4. Unlike, so not the same, or not alike, are fractions that have different denominators. So if I had 3/4 and 8/10, they would be unlike fractions. The least common denominator, you will also see this listed as LCD, is the smallest multiple that both denominators have in common. So in this case, my denominators are 4 and 10. So I want to find the least common multiple between the two of them, which would be 20. So your LCD, that least common denominator that you can make, would be 20. Equivalent fractions. So when we talk about equivalent, I really like to use the example of money. So if one person has a dollar bill, but then this other person has 4 quarters, we know that both of them have the same amount of money. Even though this person has 4 of something, they're worth less. So when you put them all together, they're equal to the same as that single dollar bill. So even though they look different, they're all worth the same amount. Same idea with your fraction. So a good example for this would be something like 1/2. If I have 1/2, so 1 out of 2, that would be the same thing as saying I have 2 out of 4. They're equivalent. Okay? It's just a matter of if I have a circle, so here's my circle, and here's 1/2. Well, if I draw another circle and I cut it in half, but then I cut it into fourths, 1, 2, that's still going to be the same amount. They're just shown differently. So like we said here, these quarters are smaller in size or value. Same thing with your parts here. These 2 pieces are smaller in size, so when you put these 2 pieces together, they're the same as the 1 piece from the half. So equivalent fractions have the same value but look different. Improper fractions, they're big on top and little on bottom. So for example, if I have something like 5/4, means I have 5 pieces and I put 4 in each group, which means I should be able to make a whole group, and that's where mixed numbers come into play. So mixed numbers have a whole number and a fraction. So here, if I have 5/4, so here's a fourth, here's a fourth, and there's another one, right? 5/4, that's the same thing as saying 1 1/4. And just not cutting up that box. It's the same amount, again, like your equivalent fractions, same amount, different way of showing it. All right, so let's go ahead and head to the next page. So when we're adding with fractions, it makes sense here. So I have 1/3, and I have another 1/3 because both circles are the same size and they're cut into the same size pieces. So it would make sense that when I go through and I add those two pieces together, that I'm going to get 2/3. It works. I can take this piece that is right here and add it on over here. But then now, what happens when I have pieces that are different sizes? So I have 1/3 plus 1/2, but my sizes aren't the same. So how do I give this as an answer? Because this is what it would look like, but how do I give that as an answer? Well, let's take a look at what's happening when we do that. So when I have 1/3 and 1/2, I can't add them together the way that they are because they're not like fractions. Their pieces aren't the same size. So I can't think of it like those toys that you play with. You have to put the square peg in the square hole. It's kind of like that. I can't put a 1/3 into a group of 1/2. I have to make them so they are the same. So what I'm going to do is I'm going to look at 1/3 and 1/2, and I know that both of them, if I cut the pieces smaller, okay, if I look at 1/3, if I cut each of the pieces in half, now all of a sudden this, where it was just worth one piece, it's now worth two pieces. So here it was worth one and now it's worth two, but the piece is still, the shaded area is still the same size. It's just now, instead of being worth 1/3, it's worth 2/6. All right, well, I can take half and I can do that to my half as well, cut it up into 6 pieces. Now my pieces are the same size, so now I should be able to go ahead and add them together. 1/6, 1/6, 1/6, which makes sense because here this is 3/6. This became 2/6. Now I should be able to add them together, and when I do, my picture will make more sense and tells me that I have 5/6 colored in. So that's what's happening when we're making equivalent fractions. Let's take a look at how to do that without drawing a model. So here's our problem set up with numbers. So the first thing that I'm going to have to do is I'm going to have to find the least common denominator of both of my denominators. Now, the key here should be the word denominator. That should help remind you that you're looking at the bottom numbers and you're looking for the smallest, because of least, smallest, and then same. So we're looking for the smallest same denominator that both of these can create. And to create them, we have to be able to multiply to them. So let's take a look at those multiples. We have 3 and we have 2. The multiples of 3 are 3, 6, 9, and 12. Some of the multiples of 2 are 2, 4, 6, and 8. I know 3 and 2 don't work just from the get-go. 4 I don't see in both, but 6 will work. So the LCD for both of these is going to be 6. It's the smallest number that I can multiply both denominators to that will allow me to make equivalent fractions. So to do those equivalent fractions, I'm going to use my new denominator and multiplication to make that happen. So I have to look at it and say, okay, 1/3 times what gives me 6? Keeping in mind that this what that's there, that missing number, has to be equivalent to 1. So if I have 4 times 1, I know that it gives me 4. Okay, so when I multiply by 1, the value doesn't change. Oops, I should make sure I put doesn't in there. So that value doesn't change. So 1, remember, can be represented by 3/3, or 2/2, or 100 1/100ths. So as long as this value right here that we're going to multiply by is equivalent to 1, we're good to go. What that means is I'm making sure that I do to the bottom what I do to the top. So looking at this, if I take 3, when I took those thirds, I cut them into each one piece, I cut it into 2 pieces. So I took all 3 of my pieces. So let's go back here and look. I took all 3 of my pieces and I cut them into 2 smaller pieces. All right, so mathematically, what that meant that I did was I multiplied by 2. I'll get my steps back here for you. There we go. And what I did to all three pieces had to have happened to the one piece. So that one piece also got split into two, and that one piece turned into two pieces. So then the next thing that I'm going to look at, so my equivalent fraction to 1/3 is 2/6. Then I'm going to look at the next problem. Or the next fraction, I'm sorry. So the next fraction, we took those halves. So we took each of the two pieces and we cut them into 3 smaller pieces. And then what I did was, when I did that to both pieces, that meant I had to do it to the one shaded piece. So the one shaded piece went from one big piece to 3 smaller pieces. So now, instead of having it look like 1/3, it looks like 2/6. Same value, just looks different. And now instead of looking like 1/2, it looks like 3/6. Same value, just looks different. Okay, so then the next step after that is going to be to add or subtract. In this case, we're going to add because that's what the problem tells us to do. We're going to add our new fractions, and we have to keep them in the same order. So before, it was 1/3 plus 1/2. So I'm replacing the 1/3 with 2/6, and I'm replacing the 1/2 with 3/6 because those were their equivalent fractions. And then when I added them together, 2 plus 3 is 5. And then remember, I don't add the denominators. The denominators just tell me how many I want in each group or the size of my pieces, and the size is still 6ths. Let's go ahead and try some of these on our own. So what we're going to do, we're going to go through the 6 different examples. If you feel like you are good to go, you can try these on your own, but I do want you to come back and check your answer. If you check your answer and it's incorrect, please watch the explanation and try to find your mistake and fix that mistake in your notes. You can also do the first one with us and then try the second one on your own, and so on and so forth. It's completely up to you. All right, so here they're not like, so I have to make them like. And the LCD, so I have 4 and 5. So 4, 8, 12, 16, 20, 5, 10, 15, 20. So I know 20 is my LCD, which in this case, it does work out that we're just multiplying them by each other. So 3/4 and 3/5. So now I'm going to multiply. So I have to multiply them both by the same thing to get 20. Now, what I mean by that, I have to multiply my numerator and denominator by the same thing. I do not have to multiply both fractions by the same thing. So here, to go from 4 to 20, I have to multiply by 5. What I did to the denominator, I have to do to the numerator, and I get 15. To go from 5 to 20, I have to multiply by 4. So since that's what I did to my denominator, that's what I have to do to my numerator. And when I do that to my numerator, I get 12. So in this case, when I add, I get 15 twentieths plus 12 twentieths, and that's going to give me 27 twentieths. Now I can't leave my answer like this because it's improper, so I have to take my 27 and put it into groups of 20. That'll make one group, and it'll use 20 pieces when I make that one group. I'll be left with 7. So that tells me that this is one whole group with 7 pieces left over out of the 20 that make a whole group. So let's go ahead and try the next one. I have 6 and 4. So 6 and 4, 6 and 4, 6, 12, 18, 4, 8, 12. So 12 is my least common denominator. That's nice. It makes it smaller than 24 if I had just multiplied them by each other. So here, I don't have to worry about the 1 and the 2 until I actually do the adding. So I can actually ignore those for now. And I'm just going to convert these to like fractions by making equivalent fractions. And here, I'm going to see if I can change the ink color so you know which one goes with which problem. I'm going to erase here, make it a little nicer for you to see, or easier for you to see. So 2/6 has to be multiplied by something to make it into twelfths. And then 3/4 has to be multiplied by something to turn it into twelfths. That something for 6 is 2, so what I do to the bottom I have to do to the top, and I get 4. Excuse me. And that something on the bottom, or here for 4, is multiplying by 3. What I do to the bottom I have to do to the top, and I get 9. So now when I add, and I'm actually going to set it up like I do normally with addition problems, so I'm going to do 1, and now instead of 2/6, I'm going to put 4/12, because that's what I replaced it with. And then here I'm going to do 2 and 9/12, because that's what I replaced it with. 9 plus 4 is 13/12. 1 plus 2 is 3. I can't leave 13/12 like that. And I know that if I take my 13 pieces and put them into groups of 12, I can make one whole group. And then I'm going to be left with 1 left over. So I'm going to add that 1 to the 3, and I get 4. I have 1 left over when I do that out of 12. All right, so let's look at the next one, 8 and 12. I'm going to change my ink color again. 8 and 12. So I have 8, 16, 24, 32. I have 12, 24. Oh, look at that. 24 it is. Can you imagine if we had just done 8 times 12 and done it that way? How large that number would have been? My goodness. All right, so here I have 5/8. And I'm going to multiply it by something to get to 24ths. Here I have 7/12, and I'm going to multiply it by something to get to 24ths. That something here is going to be times 3. What I do to the bottom, I have to do to the top. And I get 15. Here that something is 2. What I do to the bottom, I do to the top. So now I have 1 and 15/24 plus, and then I just have 14/24. I don't have a whole number here, so I can put a 0 if I want to, but I don't have to. I get 19/24 and 1. This is not improper, so I can leave my answer as is. Okay, so the process for subtraction is very much so the same. It's exactly the same, except for at the end you subtract instead of add. But what I want you to be able to do is I want you to be able to subtract when you have to regroup. So we're going to go ahead and go through all the examples. So if you need some more practice, you can have that practice. Otherwise, please make sure that you watch the examples of how to subtract using regrouping. So looking at how to subtract with the mixed numbers and fractions. So these last 2 problems here and here. All right, so again, we have to make that common denominator. And let's go ahead and change my pen color to, how about blue? So 4 and 2, well, the nice thing here is I know that I have 2, 4. Well, 4 is what I want to get to. So the beautiful part here is I don't have to change 3/4 because it already has a denominator of 4. I only have to change 1/2. So I have 1/2, and I have to multiply it by something to get me 4 as a denominator. That something is multiplying by 2. What I do to the bottom, I have to do to the top. 1 times 2 gives me 2. So now my new problem is 3/4 minus 2/4. And my answer would be 1/4. Don't you love it when they're nice and simple like that? Let's go ahead and take a look at what that looks like with mixed numbers. So here I have 5 and 4. Well, from up here, from this problem at the top, I know my LCD is 20. So I don't have to list the multiples. I just know that that's what I have to change it to. So I have 4/5 times something has to get me to 20. and I know that I have 3/4 times something has to get me to 20. So 5 times, well, that's going to be 4. What I do to the bottom, I have to do to the top, and that gives me 16. And here, 4 times 5 is what's going to get me 20, so I have to do that to the top, and I get 15. So now my problem becomes 1, and this is where it's really important. 16/20 goes with 4/5, so that has to go with the 1. I cannot make that mistake of putting them with the wrong number, or I'm going to get an incorrect answer. And then I'm taking away 15/20. The nice part here, 16 minus 15, it works because my larger number is on top, and I'm left with 1/20. 1 minus 0 is 1, so my answer is 1 and 1/20. All right, last problem, and this one I really, 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 really need you to make sure that you are focused on, because this one can be tough because it is going to involve regrouping. So I have 1/3 and I have 3/9. So I know, so 3, 6, 9. Well, 9 I already have, so as a denominator, so I only have to change one number. So 1/3, or 1 fraction, not one number, I'm changing 2 numbers technically, but I have 1/3, and if I multiply it by 3, so 3 times 3 gives me 9, and then 1 times 3 gives me 3. All right, so I'm taking 1/3 and I'm multiplying it by 3/3, and therefore changing it to 3/9. Now my problem is 2 and 3/9. Remember, we have to make sure to put the pieces in the right spot, and I'm taking away 5/9. Now this is where we have to remember, I have 3 minus 5. So if you only have 3 markers, can you take 5 away? We can't. If I were doing this, so if I had 13 and I was subtracting 5, I would borrow from the tens place and turn that 1 long into 10 cubes. So then this would become 13. So I'm borrowing. All right, so here we're going to do the same thing. We're going to borrow or regroup. And I have to borrow from the whole number. So now I have that whole number, but that one whole in this case, remember, these are 9ths that we're working with. Okay, because we have the 3/9. We know that our pieces, 1, 2, 3, 1, 2, 3. So this is what we're working with. So 1 whole is actually equal to 9/9. So when I borrow that 1 whole and take it from whole number world into fraction world, I'm not adding 10 in this case, I'm only adding 9 pieces. So this is plus 9/9. Okay, so then instead of being 2 and 3/9, this is now 1 and 12/9. Now I know it's improper, but think of it, when we did 13 minus 5, we did kind of the same thing. We put 2 numbers in the same place value, and really we're not supposed to do that, but we can do that when we're subtracting, so we can make it work. So here I have 1 and 12/9, and I'm taking away 5/9. Now I can do that. 12 minus 5 is 7, and it's still 9ths that we're working with, and 1 minus 0 is 1. All right, so what I'd like you to do is I'd like you to practice these problems on your own. If you have questions, make sure to write them down or send them to me in an email, and then we will go over them when we get to class.